Acceleration. Acceleration is the change in velocity and the amount of time it takes to change its velocity. So we can have the A is equal to Vf minus Vi over t, where A is acceleration measured in meters per second squared. Vf is final velocity, how fast we were going at the end of this time travel, meters per second. Vi is initial velocity, how fast were you going when it begun, and t is our time interval, how much, the amount of time it took for you to travel from this speed to this speed, or increase your rate of speed from that to that. We can see that acceleration can be changed in a couple of ways. You can speed up or increase your velocity, that's a change in velocity. You can slow down or decrease velocity, again that's a change in your velocity or acceleration. And you can change direction, because remember that velocity is based on displacement. Displacement was not only how fast you were going, but the direction at which you were traveling in. So we can have a negative velocity here. We can have a negative acceleration as well. So we're going to look at a couple of examples on how to use this particular equation. So we're going to start off with a bicyclist here who is riding left direction with a velocity of 14 meters per second. After a gust of wind that lasts 44.0 seconds, the bicyclist is moving with a velocity of 20 meters per second. What is the acceleration of the bicyclist during this time? So using our process, we're going to go through how to solve for this particular problem. So the first piece of information is we know a bicycle is traveling left direction with a velocity of 14 meters per second. So our initial velocity is 4.0 seconds. Now it's saying that the cyclist is moving with that velocity over 4 seconds after the gust of wind has come. So there is a velocity here, and then a gust of wind comes and it lasts for 4.0 seconds. That's our time factor. After the 4.0 seconds has occurred, the velocity has now changed to 20 meters per second. So we have a final velocity, 20 meters per second. So we have our variables identified, and the question at the end is, what is the acceleration during this time interval? So acceleration is our unknown factor. Now if we remember our directions, this says left, so we have to say that this number is negative. And at the end, he's still moving to the left at 20 meters per second. So it's negative because the wind lasted 4 and it increased the speed, so it was going along with him. So what equation are we using? Well, we're looking for acceleration, and so we have a very basic view of this equation. A is equal to Vf minus Vi divided by t. So now let's replace our numbers, if we can replace them, just the way we did with the speed thing. So if you see here, we've got a time factor of 4, so we're going to put that there for t. We have an initial velocity of 14, so that one's going to go there. And then we have a final velocity of 20, and that one is going to go there. So what has happened here is that our velocity increased. We saw an increase, they sped up. So let's look at the substitution part of this. I don't have a number for A, I'm going to keep writing it. I have a number for Vf, that is 20 meters per second. And that's minus because it's still going to the left. And we have an initial velocity of 14. So minus a negative 14 meters per second. And then we do have a number for time. Our time factor was 4 seconds. So if we continue our substitution solution thing, I have negative 20 minus a negative 14. So I end up with a positive number here, so it's minus 20 meters per second plus 14 meters per second over 4.0 seconds. So again, we continue with our math stuff. Negative 20 plus 14 gives me a negative 6 meters per second over 4.0 seconds. So now we're down to the last thing. We've taken care of all the other math. So now acceleration is the value of 6 divided by 4, which is 1.5. So over here, we're going to put A is equal to 1.5. Now, if you notice, a negative divided by a positive is still a negative. So this is still negative, giving us an indication of direction, which is to the left. And the unit here is the combination of meters per second per second. So we could write it as meters per second on top divided by seconds. But it's a lot easier if we just combine our seconds. We've divided by seconds 2 different times. So we can say negative 1.5 meters per second squared. That is where our meters per second squared came in over here, because I'm dividing by time for the velocity and dividing by time again for acceleration.